yesterday, get out a piece of paper and write down chapter 5 problems. If you were gone yesterday, get out a piece of paper, write down chapter 5 problems. I'm going to keep on showing this to you, but if you take a picture, then you have it. That's probably a much smarter idea. Before we start. Thanks for waiting, it's after night.
Are we just going to the problems for chapter
5 and 6. 5 and 6. Well, hold on, you have to grade, because you don't know the answers yet, so you're going to grade 5. Then if you don't have any questions on what we graded, then you're working on 6. If you've already finished 6, then you're working on 7, but when we grade 6, you better make sure you grade to make sure it doesn't get everything, so you can keep on working. So when we're grading, no one has headphones in? Caleb, thanks, pay attention. When we're grading, no one has headphones in, but then as I start in questions, because I am good on this chapter, then go ahead and move on as you're doing. Sound good? Okay. So we're going ahead and taping. I have chapter 5 here and ready. But before we go and ask questions on 1 through basically 11, 1 through 6, 9 through 11, let's grade. Okay, here we go. For chapter 5, let me give you guys just a moment. Here are the answers for 1 through 6 and 9 through 11. Here are the answers for 1 through 6 and 9 through 11. If you guys want, you can also with your phones, if you don't want to look up the video later, you can also with your phones, if you don't want to look up the video later, take a quick picture if you're not ready to check now so that you can check later. If you're not ready to check now, you can take a picture and check later. But today is our day for questions. If you're looking up there, you're like, I don't know how to do this type, make sure you ask me in just a second. What did you do that? Oh, because number 12, I don't see any workshop. I see you actually haven't gotten that. Oh, wait, the video's on my phone. There is no tomorrow. Yeah. Now, this is makeup work. Go sit. That is makeup work. Alright, kiddos. So you should be almost done checking 1 through 6 and 9 through 11. Yes. Huh? Let me go ahead and get this annoying screen off for you guys. If my computer decides to work. Okay. Others who haven't gotten chapter 5 done yet, have you gotten a picture of the answers? Or are you going to look on YouTube to get them?
You're all
Yes, ma'am.
I'm sorry, Miss.
I will.
Alright, those of you guys that did check, or screen off. There you go. The picture will be up for about 5, 4, 3, 2, 1. Okay. Let me go ahead and get the chapter 5 chapter test up. If you got all of those right, you got 10. Okay. This final is going to determine whether about 75% of you have summer school. So let's just shut our mouths, stop distracting others, and start caring about your summer. If you can't care about your grade, care about your summer. It's about to be gone. 1 through 6, 9 through 11. What questions do we have? Oh. Number 4?
4, 5 actually.
Okay. 4 and 5. What else we got?
Number 1. Number 2.
We did 2 yesterday, I think.
Oh, yeah, we did 2 and 3 yesterday.
Yeah. So you can check out the video. Why I said that, you can check out the video for that one, alright? So I have number 1, number 4, number 5. Diego, anyone?
Yes, the number 11, please.
11. Okay, any more? Ian. Time. Ian. I'm gonna do the best I can to try to cover as much as I can, alright? So I have 1, 4, 5, 9, 10, and 11. If you don't need these questions, you're moving on. You may put in your headphones if you don't need any of these questions. Listen, that's a loud sound? Okay, we should be good. I don't hear it. I should be good. Okay, so then as we come, we're gonna go ahead and start with number 1. Kiddos, remind me from yesterday, when you have systems of equations, 2 equations, pairs of equations, what are the 2 ways that we can solve? The best 2 ways. Substitution is one, elimination is another. Why on numbers 2 and 3 did I use substitution yesterday?
Because you already had the y self one.
Good, you had y by itself. And so when we had y by itself in the examples from yesterday, which is on the page before, remember, I was plugging in. And so I was plugging in the y, what y equaled 4x plus 4. And I was plugging in the y, what y equaled 3/5 x plus 5. And then we were supposed to be solving each of our equations, right? What's different with number 1? Why might I not use substitution?
Because you can
Number 1 is
Add straight down.
Your y is not solved.
Does that make sense? Now, the y's aren't going to cancel, but what is going to elimination? Eliminate. Something
X,
goes away.
the X.
The x's are going to go away. So then as I go ahead and try to think about, let's see if I can get this a little smaller real quick. Let's see if I can bring this in. Huh. The window doesn't get smaller, that's good. There it is. Okay. Thank you for letting me get to that. Here we go. So then for number 1. My advice would be elimination. It's not the only way, but I would say it's a good way. So I have 8x plus 3y equals -9. And negative 8x, what's the y? Plus y? Keep going, equals. I'm going to go ahead and say I think elimination is the best idea. What happens to my
They
x's?
go away.
0, right?
4y equals 20.
What number
When there's no number in front, 3 plus 1. Does that make sense? 3 y's plus a y is 4 y's. And then equals 20. Good. Then we just solve y equals 5. Now, hold on. We're almost there. That's half the answer. How do we finish the answer?
Plug in.
Yeah, we got to plug in. Now, we technically have options. I'm going to go ahead and say, you know what, for my final answer, the y being 5 is half of it. But when I go to plug in, does it matter which one I plug into?
Nope.
No, I get to choose.
Just do the beginning
What do
one.
you want? The top one or the bottom one? The bottom one? Okay, so I'm gonna go ahead and take the 8x, sorry, negative 8x, plus, I'm gonna plug in my y equals 10. My y was 5. So when I subtract the 5, solving my equation, 8x equals 24. And when I divide by 8, x equals what? Hold on. Oh, thanks, I didn't write it down today. So if I have each of my pieces, plug it in. Now technically, guys, in the answer key, didn't it say something spiffy like consistent? It only said consistent. Oh, it didn't even say. Never mind. It just said elimination was a good idea. I agree. 2 and 3, we said substitution was a good idea. The answer key says yes as well. And you guys can check the answers that we did yesterday. I think we got them right. Someone else had a question on number 4, so let's go check that out. Just looking at number 4, that's chapter 6. We don't want that one. Just looking at number 4, what do you guys think? Substitution or elimination? I think substitution. Why? Aiden, do you have a reason why? I like substitution. Does anybody else have a reason why? Aiden was right. For number 4, why use substitution? Exactly. You have a variable by itself. You know who x is. And so if you know who x is, if I pull back up my notes, that means that I can say x is y minus 11 in question, kiddos. Where am I going to put that in? The other equation into the x spot, right? So x is y minus 11, which is y. We're going to go ahead and take that second equation can say y minus 11, which is the x, minus 3y equals 1. So we're starting our problem, we're taking that second equation, plugging in y minus 11 for the x value.
What's the x's?
I do that just in case, like for instance, if I was to plug into the y, see how I need the 3 to multiply?
Yeah.
So I just put parentheses whenever I substitute because it makes sure that I
It
don't
doesn't
make
really mean anything. You don't have
In
to.
this one, it doesn't mean anything because I am going to say there's like a 1 in front. And with a 1 in front, is that going to change anything when I go to get rid of the parentheses?
So I did that and I added 11.
You can add 11 to both sides. And then don't we have two y terms? Can't we combine some like terms?
Yeah.
So we have y minus 3y. And remember, if there's no number in front of y, what do we assume is there? Good, there should be a 1 right there, right? So we can do, 1 minus 3y is, I think Kaylee already said, negative 2y. And we can solve for y by dividing both sides by?
-2.
So what does y equal?
-1.
Negative 6. 12 divided by 2. 12 divided by 2. Now that's 1. Remember, how do we go find the x if we have a y? Yeah, plug it in. Does it matter which one? No. But which one do you think is easier if we already have x alone in this one? Yeah, I would say that too. So we go ahead and say, all right, let's go ahead and plug in x equals y. Isn't that negative 6? Minus 11. So I'm plugging in my negative 6 into my y spot. There it is. What's negative 6 minus 11, everybody?
-17.
So final answer is negative 17. Negative 6. And the answer key hopefully backs us up on that. To make sure that we didn't make any silly mistakes. Got it? Alright, you guys seem to do okay-ish on 5 and 6. Oh, no, there was a question on 5. But you definitely didn't like 9, 10, and 11. So let's go look at number 5 really quickly, and then we'll look at numbers 9, 10, and 11. So for number 5, those were missing. Okay. What's going on number 5? Oh, okay, I know I don't like number 5. But first of all, question, what do you guys think? 6x minus 4y equals 9. And 9x minus 6y equals 15. What do you guys think is a good method? Substitution or elimination? For number 5. It looks like elimination because we have x's and y's and numbers, right? But the problem is, can I just add down the way it is?
Yeah.
Oh, but is anything going to eliminate? Is anything going to cancel?
Yes.
No, but if I go down right now, isn't 6 and 9 going to make 15? X, and isn't negative 4 and negative 6 going to make negative 10y? I need somebody to go away. I need a variable to go away. Perfect. Exactly. I need to make them to be the same number. Now, I'm going to add to that just a little bit and say, not just multiply to make them the same, but make them opposite. So, can we make 9 into 6? Or 6 into 9? Oh, I can make 18. Can I make 6 18? What am I going to multiply everybody by to make 6 into 18? 3. And how am I going to make 9x into 18? Why am I going to put a negative 2 all of a sudden? I need them to be different signs. So I'm going to go ahead and bring this 3 basically into everybody, all the way across the equation. So 3 times 6 is 18x. 3 times 4? 12y, and then 3 times 9. Yeah. I need the other equation also. What's negative 2 times 9x? Give me 1 second. Negative 2 times negative 6y? Uh-oh, this isn't looking good. And negative 2 times 15. What happens when I go to add down now that I've gotten 2 times 4? Yeah. 18 and negative 18 cancel and I get a 0, right? Uh-oh, what happens to the y's?
They cancel out 2.
What happens over here on the left hand, or the right hand side? What's 27 minus 30, John?
Not negative 3.
Not negative?
Yeah.
So good thing it's negative 3. But here's the question. Does 0 equal negative 3? Here's one of those special weird things that happens. True or false?
False.
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 They're different numbers. What do we say when we have false?
Zero with the hole.
Yeah, we can say this, but maybe a better way of saying it is no solution. But here's a long story short. There's no x with no y. There's no 1 point. There's actually not any point. No solution, and if you guys want to remember the snazzy word that goes along with it in case it shows up on your final, it's inconsistent. I'm in a box, no solution, aka inconsistent. Rob, use the trash can and get back. Don't go to the trash can again. Alright, let's go to 9, 10, 11. You guys didn't like the graph one, so go ahead. The highest sum of the powers of variables in each term.
So is that in the answer or in the question? Like in the first column or in the answer?
In the polynomial we do. Does that make sense? But it's the highest. Don't add the entire thing. It's the highest of each. Alright, kiddos. 9, 10, 11. Why didn't you like them? I understand.
Because they 11.
No. 9, 10, 11. Why didn't you like them? Graph.
Because it's the graph part.
No, wait a second. Let me finish chapter 5. Very nice. Is it on 5? There. It's on a future one. 9, 10, 11. We have to graph. And in order to graph, we have to get lines on. We have to get lines on an x and y axis, right? I don't know why everyone's laughing over me. But we have a final, and I really don't want you to say summer school. Here we go. So for 9 and 10 and 11, inequalities. You guys already saw in the answer key that we have shading going on, right? Okay, but before we can ever get these graphs, we have to go ahead and make sure we can get y equals mx plus b. So I'm going to go ahead and for 9, 10, and 11, let me get the book back up. Here it is. I'm going to write down each of these equations. Kiddos, are these equations ready to go as is? Are they already in y equals mx plus b form?
No.
So first things first, we need to get all the y's by themselves. First things first for 9 and for 10 and for 11. And I'm going to go ahead and start there. We need to get the y's by themselves. So question, is the first one, is the y already by itself?
Yes.
So how about the second one, is it by itself?
How about 2?
Okay, so we have to get the 2 out of there.
Get rid of the
So we're going to divide this side by 2. And just as a shortcut, we're going to divide each piece on the other side by 2 also. So I'm going to go ahead and pull up my notes really quickly and move it so that you guys can actually see the question off to the side. So for number 9, the first one's great. Y is greater than 1/2 x plus 4. We have y and mx and b. But the second one, if I divide everything by 2, the 2 goes away with the 2y. The less than or equal to is still there. Question. If I divide x by 2, is it the same thing as 1/2 x? Okay. X divided by 2, 1/2 x. What's going to happen when I divide the 4 by 2 also?
It's going to equal 2.
Good. Now I'm going to go ahead and do the same thing for numbers 10 and 11 because I need to go ahead and make sure that I have all of these y's by themselves. Otherwise I can't really do the problem so good. So for number 10, are either of the y's by themselves? Not yet. How do I get the y's by themselves? Guys, whoa, we're in algebra. How do I get the y by itself?
You
Subtract the x. X minus x is 0, right? What am I going to do with the 5x? Subtract it. Okay. Good. Whew, you scared me for a second. So, in order to get y by itself, I need to subtract the x on the first one. And I need to go ahead and subtract the 5x on the next one. You guys see it? Are we okay? Close the pen. Put it down. Make sure your hands are empty. Hold them on your desk and just leave it alone. Number 11. Y is already by itself in the first one. How do I get y by itself in the second one?
You have to put the x here.
How?
But by glass.
Adding the 3x.
Adding
So now that I have each of these pieces ready, now we just need to look at the graphs and see why you guys got a little bit confused, okay? So we have negative 2/3 x. What was it, plus 1? Plus 1.
Yeah.
You guys told me for the second one that we need to add the 3x to the other side, and you're totally right. Alright, now we're ready to go. We got a graph. So in order to graph them, don't we need like x's and y's, guys?
Yeah.
So I'm gonna go ahead and get my x and y here. I'm gonna get my x and y here, and my x and y here. I'm just being approximate, right? I'm not gonna be all snazzy graph paperish because I don't have graphs. I don't know if I can make a graph.
That's crazy.
That's cool. There we go. That's snazzy. Okay. I'll make it a little bit prettier then. How do we graph a line? That's a big idea from algebra. How do we graph a line? I think a little different heights that way they're not all running into each other. Okay, how do we graph lines? Y equals mx plus b.
Oh, you first put it forward.
Okay.
Put it.
So as we look at each of these up here,
Oh, right, yeah. 4.
y mx plus b. Start with the 4. Good. We're going to go up 4, and then we're going to do our slope. What are we going to start with on this one?
2.
Go up 2. So I'm going to go ahead and,
That's 4.
let's see, let's make the top one blue and the bottom one green. Is that good? So bottom ones will be green, top ones will be blue, just so we can kind of keep them color coordinated. So for the first one, I'm going to go up 1 and 2 and 3 and 4. What do I do with that 1/2? Okay, I have up, down, and right, left, right? I have choices, up, down, right, left. Slope is rise over run.
Yes.
Slope is rise over run. So, if I have 1 and if I have 2, they're both positive numbers. Do you guys remember? Am I going to go up 1 or am I going to go over 1?
Over 1. Over 1. Up 1.
Down. Rise
Over.
over run. So rise, go up 1, run over 2.
Oh.
That, you guys remember slope?
Wait.
Rise over run. You might need to write that down. M equals, or slope equals, rise over run. So up 1 over 2.
Oh.
Up 1 over 2. And remember, it's a positive number, so
where did you get the 1 from? The 1/2.
it's written.
Plus 1. Oh.
If it's a positive slope, we're going uphill. That's another quick way to make sure you're doing it right. So go up 1 over 2. Up 1 over 2. You see it? I can go the other way, down 1, back 2. Down 1, back 2. Long story short, I have my line. If I connect all my dots. Do you guys remember whether I'm connecting with solid or dotted based on the greater than?
Yes.
Solid or dotted? Remember, if there's a line, we make it a whole line. If there's no line, we make it dashed. So the first one's going to be dashed. No line, dashed. Line, solid. So for the green one, I'm going to go ahead and go up 2, because it's mx plus b. Up 1 over 2, up 1 over 2, up 1 over 2.
Oh,
Back 1, left 2, back 1, left 2. This one's going to be a solid line because it's or equal to.
Oh, that makes sense.
Now, the only thing we're missing right now is the shading.
So do we have to shade?
Or if it has a greater or less than. So let's help out. Hold on. We're on the blue one. Greater than. Do you think we're going above, higher, or below, lower? Yeah. Greater than, higher.
Higher.
So we're going to shade higher than the blue. And then what's this one?
Below.
Less than. So we're going below the green.
Okay, so I'm reviewing.
So we're going to go above the blue. And we're going to go go below the green. Kiddos, does this match up with what we saw a second ago in the answer key?
Wait, why did you go above?
Yeah, one more time. The above and the below. Yeah, Caleb, can you explain it? So we went above the blue because greater. So greater means above, less than means below. Good job. Good job. On number 10, I'm just going to go quick now, kiddos, except some of you might get a little stuck on number 10 because of the slopes. Stop. -5 doesn't have an over. So I'm going to go ahead and make it over. I'm going to make 5 over 1. Oh, you guys can see it.
Oh.
See it now? No. That's good on mine. Oh. Okay. Let me quickly turn this off and see if I can turn it back on. Okay, now it's happening. I don't know what's going on. Alright, kiddos. So, for the 5, it was just -5. I'm putting over 1 because I need rise over run.
Oh, yeah.
What's the number if there's nothing by the x?
1.
1 over
1.
1. Exactly. I need rise over run. So I'm going to have -x will be -1 over 1. So as I come back down below, I'm going to start at 1 because of this little +1 right here. I'm going to go down 1, right 1, down 1 over 1. And remember, it's a negative slope. So when I go down, it's going to end up negative slope, it's going to be downhill. Positive slope, up. So I need to go from my initial point, right? From my +1, which was this point. I had to go down 1, right 1, down 1, right 1, down 1, right 1. Because of the negative. Okay, go okay?
Yeah.
So I have my downhill line. I can go ahead and camp that guy. Good, you guys are already getting started with this one. Wait, why did it get solid though? What's it supposed to be?
That's supposed to be
Dash, because it's not or equal to, right?
Oh, yeah.
like that.
I
Over
forgot
that.
that too.
Okay. Alright. Guys, it's time for the green. Where are we going to start for the green? Good.
4.
So 1 and a 2 and a 3 and a 4.
Oh my gosh.
Then I'm going to go
Down.
down 5. 1, 2, 3, 4, 5. Over 1.
One.
See how far I go down? And down 1, 2, 3, 4, 5.
Over.
Oh, it's like way down there.
Yep. Like right there.
There we go. Solid or dash?
Dash.
Good, because it's not or equal to. Hold on, you didn't shade yet, right? For blue, am I going below the blue or above the blue? Below. Why? Less than. So below the blue, and what am I doing with the green? Above or below?
Above.
I'm gonna go below the blue.
Wait, so if you guys have the line under right there.
Make it dash.
Then dash is isn't like
Yeah, good. I'm looking for the intersection where they're both shading, both colors are. So remember we pick a third color. Where are both colors? You guys see where they coincided?
Yes.
See it? Right here.
Whatever that is. Orange.
Yeah, I just made it like something random.
Orange.
So the overall answer is where the two colors were, which was right in here. Does that look like the answer key? And the answer is once again, yes, if we go back. See? Did we get that triangle? Yeah, we did.
Indeed.
We got a triangle.
Yeah. So as I go back, number 11. Nice thing is, kiddos, is that you have a lot of experience with this now, so I'm going to go fast. We're going to start the blue at +1. We're going to go down 2 and right 3. Up 2 and left 1, 2, 3. Why am I going to make this line solid for blue?
Because it's greater than
Or equal to. Good. Why am I going to shade above for blue?
Because it's greater than.
Because it's greater than. You guys remember this now a little bit?
Yeah.
For the green one, where am I gonna start my graph?
Wait, what?
At
Down
-2. I'm gonna go up 1, 2, 3 over 1, because it's a positive slope, right?
Yeah.
Over 1. I could go the other way, I suppose. 1, 2, 3 over 1. Solid or dash?
Dash.
Good, because it's not equal to. And where am I gonna shade the green? Above or below?
Above.
Is the above, can you guys tell, is above to the left or is it to the right?
To the right.
Above,
Is left.
going higher, is to the left. It's kind of hard to see at first. And then, where is the overlap? I think I'm on it, aren't I?
Yeah.
Alright. No, but there might be like a matching question where they have different types of shadings.
It'll be like, which one is the right graph?
Or remember, there is a long answer portion that we'll talk more about next week. But this might be a good big problem. You have to graph two things, you have to move equations, you have to do shading. So it might be a good long answer problem. Kiddos, number 5. Chapter 5 is done. Let's check chapter 6.
Could we do it on the same page?
Yeah. Yeah, just make sure you write the assignment first. Do you guys need to see the problems for chapter 6?
Yes.
Okay. Alright, kiddos with headphones, it's time for chapter 6 to grade. So make sure all headphones get out for grading so that you can see it. Page 351, 1 through 6, 11 through 13. I'm going to go ahead and quickly shut down chapter 5. Do you guys have any further questions on chapter 5? You can come see me after school during lunch, okay? Oh, sorry. So page 351, 1 through 6, 11 through 13. 1 through 6, 11 through 13. I have chapter 6 ready to go, but let's go ahead and go check those answers a little fast. 1 through 6, guys in the back, calm it down. 11 through 13, here we go, answers. Let's get ready to chapter 5. Let's get ready to chapter 5. Here we go. Alright, Barry, answers are up for chapter 6 if you want to check them real quick. If you guys want to take a picture, if you haven't done chapter 6 yet, take a picture so that you have it. Or it's also on the YouTube video. You would just have to fast forward to get there. Yeah. Just make sure that you put it. It's okay. Just make sure you put the numbers so I know what you're doing. No solution is if it's false, like 3 equals. Okay.
Yeah, let's start on 6. Chapter 6, the review.
Yeah, you can, but you might want to just pay attention if someone has a question. It's probably a hard problem that you might get stuck on. Does that make sense? Good. All right. Does anybody have any? Do you want me to pull up the chapter 6 review? Does anyone have any questions they already know that they want me to kind of talk through? Yeah. 12. Okay. Oh, you're good. Anything else anybody knows they want from chapter 6?
Number 3.
Number 3 looks good.
2
2 and 3?
13. Gonna do 5 too. 13.
Okay. I'm going to do 2, 3, 5, and then, well, we'll just have to do what we can. Let me start with number 12, because that was Jordan. She had that one ready. Hold on. Justin had 2 ready, Jordan had 12 ready, and then if we have time, I'll have 3 and 5 ready. Okay. So, let's start with number 2. These ones are the nasty radicals and fractional powers. If you guys haven't done chapter 6 yet, you really want to pay attention because these are the ones that people have found ready. For number 2, Justin, can you read to me really quickly? Number 2 is
729 to the 1/6.
yeah, 729 to the 1/6. Ugh. Does anything go into 1/6? No, 729. Can someone in the calculator try dividing by 3?
243.
It's 3.
It's 243.
Okay. So 729 is 3 times 243. Justin, divide by 3 again.
81.
Yeah, that's where I'm going. Good call. 81 is 9 times 9. You guys see me breaking this guy down, right? So I
That
divided
is a
by
lot of
threes.
threes.
Why did I not start with 2?
Wow, was it?
Yeah, it's an odd number. Don't start with 2, Angel. Start with 3. Kaylin? Whole body shifted towards the board. It'll help you and it'll help those around you. So guys, let's check it out. How many 3s do we have? 1, 2, 3, 4, 5, 6. Oh. So can't we say 729 is the same thing as 3 to the power of 6?
Yes.
But what do we have outside 729? What's it being raised to?
1/6.
Good, so I'm going to replace 729 with 3 to the 6th, and I have a 1/6 power. Do you remember what to do when we raise a power to a power?
Multiply.
Multiply. Multiply. So what that means is that we're going to do 3 to the 6 times 1/6. Wait a minute. What's 6 times 1/6? Or what's 6 over 1 times 1 over 6?
That's one.
Yeah, don't those just reduce to be 1s?
Yeah.
So isn't this just 3 to the
Yes.
1? Yep,
Which is
1
three.
is 3. Done. Dun, 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 dun. Just 3. Now I'm going to go ahead and number 12, because the people that had already tried it and checked their answers, they had questions on 2 and 12, and then maybe we'll look at 3 and 5. Number 12 got a little bit weirder. Remember when X's came up?
Oh.
So let me go ahead and get number 12 at the very top of the screen there, so that we can look at it. And let me go ahead and get my paper ready. Okay. So for number 12, we have an equation, right? So we have 256. Do you think 256 can be broken down? Yeah, me too. And then we have 16. Now you might not remember exactly how to do these problems, but hopefully you think that 256 can be broken down. So I'm going to take 256 and I'm going to take 16. Now I know they have these little powers, but we're going to deal with them in a second. If you just look at 256, did anybody figure out what that equals when you divide by 2, divide by 2, divide by 2, divide by 2?
128, 64, 32, 13, 8, 4, 3,
Yeah, it's just going crazy, huh? There's so many 2s in here. Whew, count them up.
Just the
1,
power of
2,
eight.
3, 4, 5, 6,
Just the
7,
power of
8. 2 to the power of 8. So I'm going to go ahead and on that left side, I'm going to say 256 is 2 to the power of 8. And then what's outside the 256? Good, I still have to put the x plus 2. Now, someone maybe is already breaking down 16.
2 to the power.
It is 4 squared, but I think 4 can be broken down also.
2.
Good. 2 to the power of 4. So I'm going to replace 16 with 2 to the power of 4. And then what's outside the 16? Yeah. I know this looks kind of crazy, but actually it just got way better because do you see how there are 2's in both?
Yeah.
Before it was 256 and 16. What do you do with that? But now that there are 2's in both.
Oh, yeah, I remember that. Cancel it.
Now hold on, not quite yet. What do you do when you raise a power to a power? Okay, so we're going to say that over here. Now careful, do you see why I'm putting parentheses if I need to multiply?
Yeah.
And then over on this side, it's going to be 2 to the power of, I'm going to put my parentheses again, right?
12. 12.
Good.
4.
So I have 2 to the, I can multiply to 8. I hear people multiplying and I agree. 8x plus 16, right?
agree.
Now, some of you guys, maybe the terminology is a little weird. But it's actually not called divide. I know what you're trying to do. Long story short, if you can get the, and it's been a while, if you can get the bases to match, we cross them off and we say, sweet, let's look at the powers. If we can get the bases to match, there's a snazzy one-to-one property of exponential functions, blah, blah, blah. So you're left with just 8x minus 16 equals 12x minus 4. Come on, algebra kids. How do we solve an equation?
So you know you got a plus and minus
can plus
on
it.
both sides.
No, wait.
We can do it two ways.
No, wait, I'm
Oh, I didn't write it right.
Yeah.
Which makes sense. So how do I get rid of 16?
You gotta
Okay.
I say subtract 4.
I wrote the sign wrong. It's plus, so I need a minus. I end up with, alright, we're staying an extra minute because Caleb's studying the
8x
clock.
equals 12x minus, minus
20, good. Negative 4 minus 16.
8x.
And then we need to move our x's together, right?
Yeah.
So if I move our x's, I think I need to get the x's to the other side.
Yeah. So it's negative 4x equals negative 20. And then you divide that, so x equals 5. Okay.
Divide by negative 4. Divided by 4, it's gonna be positive 5. Negative 5.
Divided by a negative. Okay. Kiddos, nice thing is we got to the two questions that people who had tried this section had when they were working on it. So we got to the two big questions. What is your goal this weekend? Finish chapter 6. It was technically for today. Finish chapter 6, get going on 7 and 8. So we're going to go over questions on 7 and 8 on Monday, okay? Alright. Does anybody else need a picture of the homework? We're going to get back up really quickly. There you go. Bye guys, work on this review. We got to study.
Joseph.
Have a good weekend.
Have a
Thanks,
good,
you guys too.
beautiful week.
I know, I was being nice today because mostly you guys were good. You did better. Other people were checking. Just keep on. It's nice to get back to the stuff. Just pay attention when it's checking in and the final committee is for those. Because they don't want to hear us talking.